Dear SS2 students, we continue with our online lesson. Remember that last time I discussed the reflection on a clear surface with a mirror in focus. We're able to know what a mirror is, what is reflection, laws of reflection, use of mirror, property of image formed by a plane mirror, and others. Today I will round up that topic before I move to the next topic. We have two calculations I want us to do based on that topic. The first one is number of images obtained when two plane mirrors incline at an angle. So we have plane mirrors that incline like this, another one like this. Where this angle of inclination, which is called theta. Then we ask you to find how many images that we form here. Or I can get something of this nature. Also inclined. So the simple formula is number of images formed at the end is equal to 360 over theta or minus 1. So memorize this formula. 360, that is the angle at a point, over the angle of inclination. After calculation, we subtract 1 from it. That's going to apply immediately. If 1 theta is equal to 60, the incline at an angle 60. Let us find how many images will be formed. You can come out below B here, or even theory. So n equals 360 over theta minus 1. I have emphasized about writing the formula by a calculation. Don't assume you know the formula in your brain and you cannot do it here. Then here is equal to 360 over 60 or minus 1. You divide it, let's go to 60, that's going to give you 6 minus 1 equal to 5. So we are expecting 5 images to be formed when mirrors incline at an angle theta. Remember I told you that plane mirror is used in kaleidoscope. In kaleidoscope, the two plane mirrors incline at angle 60 degrees. So number of images expected in that instrument is 5. Then let us move further, assuming that number 2 question, that theta is equal to 90. Carry out the same calculation, that is n equal to 360 over 90 minus 1 will give you 4 minus 1 equals, alright, yes, it was correct. Because 360 divided by 90 will give you 4. Then, if you move further, question number 3, assuming that theta is equal to 360. Theta is equal to 360. Then the same formula, n equal 3 theta, yes, 360 over theta minus 1. 360 over 360 minus 1, 0. So no image will be formed. Finally, number 4, if theta is equal to 0, the same procedure, n is equal to 360 over theta minus 1. You see, every time I will write the formula first, which is equal to 360 over 0 minus 1. Then, how do you do this? In this case, some will tell you it's 0. It's not 0. But if it is 0, what about this one? So here is uncountable or infinite or uncountable or multiple number of images. If you divide anything which is 0 in calculator, it will give you error. Error means that the number you're going to get cannot be accommodated in the calculator. So it is error. So the answer is infinite, uncountable, or multiple number of what? Images. Then that will take us to another calculation on plane mirror. This time, when mirror rotates, the reflected rays also rotate. That's the rotation of mirror. When mirror rotates, the angle of reflected rays also rotates. So the ask you, calculate the angle of reflected rays when mirror rotates at a particular angle, mirror rotation. Mirror rotate. So assuming that mirror is like this mirror, it rotates like this. Where this is theta, this is mirror rotates from here to here. Then the angle of rotation of reflected rays is obtained if here is theta. Angle of rotation of reflected ray is equal to 2 theta. So memorize this formula. So if you rotate by maybe 20, what angle of rotation of reflected ray? That is what? 2 times 20 equal to 40. It's going to be easier. It's going to be easier. With this, I've concluded that topic. Then today I'm going to look into a similar topic. This time we talk about reflection of light on curved surface or curved surfaces. Light reflection on curved surfaces. We have done that of reflection on plane mirror, on plane surface, at curved surfaces. Now, then we have 2 types of curved surfaces. We have parabolic and have spherical. We have parabolic, we have spherical. They're all curved. Let me handle the parabolic first. Parabolic is like this. Parabolic is that of this shape. Then this type of curved surface is used where? It is used in the car headlamp or flashlight. Then they ask you what type of mirror is used in the car headlamp. Answer is parabolic mirror. Why? Why do you use it? That parabolic mirror has one particular property. What's the property? That it reflected parallel beam of light at its focus. It reflected beam of light at its focus parallel with undiminished intensity. It reflected a beam of light at its focus parallel with undiminished intensity. When I say beam, I mean rays of light. Let me show it. Yeah, this is the focus. This is the focus. The rays, which you call beam. Look at it. The rays from this light. The rays from this light. This is the focus. The beam of light, when touching this mirror, will be like this. So see it, this is the focus, beam of light for in focus is reflected parallel. That's why wherever you may be, and somebody pointed torchlight on you, it must catch your face, no matter how far you are. The more it catches your face very close, then the more it catches your face very far. So that you're very far away, not making enough to get their face with the same light intensity. Or the car headlamp. Sometimes you see people using their hand to cover their eyes at night when the driver is driving and then pointed a light on them. So this is used. Where do we use it? One, such light like torchlight and a car headlamp. Then why don't we use spherical mirror for that? It has what they call spherical aberration. Have a problem. Spherical aberration. So spherical mirror cannot be used for that because it has a problem known as spherical aberration. That is, cannot reflect this beam of light that is focused parallel. So I'll finish on what I'm going to call it. Then I go to a spherical mirror. Spherical mirror have two types. Spherical mirror. Spherical mirror have two types. Have concave and have convex. Have concave and have convex. Then these two mirrors, they're all curved. You can squeeze them by mere touching them. When you touch the concave, it curves inwardly. It curves inwardly. The reflecting face is inward. When you touch the convex, it curves outwardly. This is inward. Look at it here. This is outward. Because I normally associate this one to a woman that is pregnant, maybe ready to deliver. You see, the woman will not be straight again. It will now, the belly will be very, is out, while the back will be in, showing that the woman is very close to her delivering point. So that's how can you remember it. You feel it. Get to me, feel it, you see it. Then let us now handle these two mirrors. I will start with the concave. You have known the shape. Then these two mirrors, they form images depending on object position. Concave mirror. But before I go, let us discuss the terms used in this mirror. So whenever I'm talking about it, you'll be following. Without being told, this is concave. This is concave. This is concave. No matter what you wash, is the severed face. The face without this line is severed. So you look at it, it's now shake off inwardly. Then this point is called P, pole of the mirror. Then for that pole, we have F. This point, capital F, is called principal focus. Beyond that, we have a point called C. This point is called center of curvature. So when I use the word pole, principal focus, and center of curvature, you know what I mean. Then distance. You know, we're summarizing this lesson in actual teaching. I will maybe define all these things. From this F to P is small f, which is called focal length of the mirror. Then from this point to P is R, which is called radius of curvature. Remember that F R is equal to 2F. That this distance multiply the focal length by 2, that is going to give you rate of curvature. Then, how do we use this mirror? This concave mirror. It is used in shaping. Men use it to shape. I told you I cannot use plain mirror to shape because it cannot magnify. Why do we use this to shape? It has the ability to magnify an image that is very, very big. But where there is no concave mirror, you can manage plain mirror to shape. So this is used for shaping. Then this mirror has a problem. You cannot use it as a driving mirror or traffic mirror. Reason for that, it produces image of different properties based on object position. You are going to see it now. Image of different properties. So sometimes to produce an inverted image, sometimes it produce a very small image. It produce a very large image. So if you use it as a traffic mirror, what is a traffic mirror? A large mirror you use to watch what is happening behind you. As a driver, you don't need to look behind while driving. You have to focus the front while the mirror will be telling you what is happening behind you. That mirror is what we call a driving mirror or traffic mirror. So we don't use it for traffic mirror or driving mirror. Now let us move to images, properties of images formed by this mirror. Properties of images formed by this mirror. We're going to get different properties based on object position. I will draw it as assignment. I will tell you to open any physics textbook and draw it. When the school is resumed, I will draw it for you. They compare what I've just drawn. The number one, object between P and the F. Now you use the word P now and F. Have know what P is and what F is. Object between the pole of the mirror and the principal focus. Image form will be, and you are going to let me ask you an exam with a good label diagram. Describe the property of image formed by a concave mirror when an object is placed between P and the F. You have to draw a diagram and then describe it. Today I'm describing it. Diagram will be later when you resume. The image produced with one, visual. 2, magnified. 3, erect. 4, behind the mirror. In OBJ, they may list these properties and ask you where will be the position of the object. That a concave mirror produces image of so property. What will be the position of the object? OBJ. It will be between F and what? Between P and what? F. So note it. You know what I mean by visually based? I've called that one. Then when you move, the first one is here. Object here. Then when you move backwards, object at F. Object at F. Number 2, object at F. Image on property will be at infinity. Image will be at infinity. You cannot see it. Don't know whether it is black or white, tall or short, bigger or rare. So it's at infinity. Then I move behind. Object between C and F. Object number 3. Object between C and F. I know what C is. Image will be 1, rare. 2, inverted. 4, 1, 2, 3, magnified. 4, beyond C. Beyond C. Then the next one, number 4, object at C, image will be 1, rare. 2, inverted. 3, same size as the object. And number 4, form at C. So watch this number 3. Then ask you a question: at what position will the object be placed in a concave mirror to give a carbon copy of to give image of a carbon copy? That is at C, the same size. Here, concave mirror act like a plane mirror. A plane mirror, remember, it gives you the same side of the object. Finally, that is discussed at C. Beyond C, when object is placed beyond C, number 5, beyond C, image will be 1, rare. 2, inverted. 3, beyond C, formed between F and C, formed between F and then C. Number 4, diminished. This is the only where you get a diminished image. Finally, when object is placed at infinity, object at infinity, number 6. Object, cannot show it here. Object at infinity. Image will be 1, rare. 2, inverted. 3, formed at F. Formed at F. Number 1, 2, 3. Number 4, diminished. So you have seen why you cannot use this as a driving mirror. See the product image formed with objects in place at different positions. So these are the product image formed by a concave mirror. Then for convex mirror is used as a driving mirror. because it produces image of the same property, no matter the object position, image of the same property. An image produced by convex mirror is 1. 1, it is visual. 2 is erect. 3 is diminished. Number 4 is formed between P and F. So you see, it produces image of the same property. Based on this, we use convex mirror as a driving mirror. Apart from producing image of the same properties, it has what they call wide field of view. Wide field of view. So, wide field of view. See it? A wide field of view. Unlike plane mirror that produces narrow field of view. Wide field of view. I will stop it here. Next time, we are going to use what they call mirror formula to solve problems on this. Mirror formula to solve problems on this. And that mirror formula says that 1 over mu plus 1 over v equals to 1 over f. You can attempt it yourself and give yourself a problem. Try it before the next lesson. With this, I say bye-bye for the lesson. Remember to continue reading, revise, and then ask questions in any place you are confused. Thanks.